Hello everyone and welcome to this demonstration of our advanced payload obfuscation framework. Today I'm going to walk you through how we've built a Python-based system that can transform simple detectable payloads into a stealthy evasive script that bypass security controls, let me put it that way. Now, first thing I want us to do is to understand the requirements we made use of, which is to import base64 random string and argument pass, where base64 is being used to encode our payloads and to hide their true nature, random to generate unpredictable variable names and structure, string for string manipulation operations, and then argparse to create a professional command line interface. Then we, in some of our other scripts, made use of the OS and path lib, which is for a cross-platform file operation. Now, what these modules do for us is that these modules give us the building blocks to create sophisticated obfuscation techniques. Now, let's look at our class structure. Now, at the heart of our tool is what they call the bash reverse obfuscator class. The obfuscate bash reverse over here, you will see the class bash reverse obfuscator. Now, notice that we have designed this in a way that it is verbose, and also verbose mode means that it allows the users to see exactly what's happening at each step. Also, we added technique trackers, which keeps a record of every obfuscation method being applied. Then we also have the modular design, which means that each obfuscation technique is its own method. Now, this object-oriented approach makes it very easy to add new obfuscation techniques and still maintain the code. Now, we also have um, the obfuscate bash reverse method over here. Now, here's the basic reversal we are working with, which is the bash-i. Here's the basic one we are working with. Now, let me break this down for you. What this bash-i does is that this bash-i creates an interactive shell, while this greater and symbol with this port number of a thing, what this does is to redirect both standard input and std out and std error, so standard output and standard error, to a TCP connection. So it redirects those two things into a TCP connection. And then this 0 greater than and 1, what does is to redirect a standard input to the same connection. Don't forget that we have the standard error, we have the standard input, and we have the standard output. All this is what is being used in here. Now, this creates a bidirectional shell channel back to our listener. But the only problem is that it is easily detected by security tools. Now, we have the obfuscation layer, and that is where we have our base64 encoding, where we have all our apply encoding layers, which is to apply our different kind of, you can see base64 encoding and string reversal over here. So this simple technique already makes the payload even harder to recognize in logs and by signature based detection. Then we have the obfuscation layer 2, which makes use of the string reversal. Now, if we have string reversal, we reverse the entire base64 encoded string, and then we store it in a variable. Do you get now? So we use this shell parameter expansion to reverse it back, then decode and execute it. So this creates multiple layers of indirection. An analyst would need to reverse the string, then decode from base64 to see the actual payload. Then we also made use of what they call the system camouflage. Just all these methods are just being put in place. You can see generate the camouflage script and everything. So we created this camouflage so that it will look legit. So what this does is to make it look like as if it's a system update, that it is not anything malicious, it's just a system update script. So it cleans this and it exits, and it works in the background. That's what this does. That's how this works. Now let's go straight to how we use this tool. Let me first explain this. I'm making use of two scripts here, which is the ping obfuscator and the bash reversal.py script. Now I'm making use of those two scripts. I'm going to start with the ping obfuscator. So for this ping obfuscator script, if I say Python 3, the script name, then the target I want my actual target to ping. If I want my actual target to see if it can communicate with my C2 server, or let me say with my machine, I have my machine address to be this. So I can take this, then say Python 3, my script name, then specify it as a target. So that is the machine that I wanted to ping back to, and it should ping it, and it should write the output. It should write my output to the file, then I specify the file name. Maybe something like ping bat or anything. I just have to specify the file name. So let me just save it into somewhere in my home directory called my desktop, and then there's the directory name. So I want to give the file name to be ping underscore test.bat. That's what I want the file to be. So in verbose mode, type in v. Then you can see that this shows you what happened, saying that there's the target, it should count it 4 times. This is the base 64 encoded string encoded as you've created payload, it was written to this place. The target IP is this, failed command injection. So system, it shows you every single thing that takes place here. Now if I send it to my Windows, for example, let's just assume I send this to my Windows. So this will be in here. If a user should execute something like this, this is what happens. It just pings that target, which is the 192.168.0.194. Here's a very simple script, and you see this is not being detected by any antivirus system. To confirm this, you can come check on the virus and threat protection, and you'll see that this is currently what? This is currently turned on or true. Now that's for that. Now let's move to our bash script itself, the actual bash script. Let's see if this will also work the same way. Now we have our bash obfuscator to be in the bash underscore reverse underscore shell.py. I'm going to say Python 3. I want to make use of the bash shell script. So it's asking that, okay, who is the attacker? Where should my listener be? Let me just say attacker. Let me say who is the listener. So my listener is on the IP address 192.168. Let me create a listener so you know what a listener is. I will be making use of Netcat to listen. On this card is my listener, so I'll be using Netcat to listen on the port 4444, or I can make use of it to listen on the port 8080. So just to make sure that I have a listener on, so this says listening on anything that's coming from port 8080. So that is on, and I say 192.168 with my IP address being 0.194. So having that, I specify my port, which is the 8080 which I'm listening on. The 8080 I'm listening on in my listener. Then -L this to say I'm setting the obfuscation level to 3, meaning that she makes use of base 64 encoding, string reversal, and then she makes use of another third way of, that's ROT 13. Then you should write it to a file using -O. Then you should write to a file called, let me make use of a file like butterfly, or since we masked it to be like a system update, it should be system update .bat. So users need to run this file to update their Windows system, or else it would be banned for life. So more like social engineering to deliver this to a target. Then -v. So you can make use of social engineering to deliver that. Let me have it as a .sh. It should be a shell script. Let me put it that way. It can also be .bat. Please take note. Your choice. Now I leave this way and run this, and this tells me that okay, it has done what I asked it to. It created a reverse shell. It used this payload. Then please note that it used this payload because I specified a payload already in my script. The only thing I asked it to replace there is the port and the IP address. Those are the two things to replace. So you can see to set up, you create your listener here, and then you transfer system to target, and you run this command and this command. So your choice, meaning that the target can run something like this, but you don't have access to the target system. So let's assume this is the target over here, and this okay, sorry, let me do this again, but this time I want to save it to my desktop and in the directory called call, so it should be saved in there. If I check now, you will see the script. So if the script is being sent to a user for a user to update their system, and the user double clicks this file to try and open this, now you see this doesn't open up. So that means .sh is shell, which is for Linux most of the time. So I'm going to be leaving this as something like a .bat script, So leaving this as a bat script, I run this, then come to my file. The user run the system updates. If you come back to your listener and you wait for if you're able to grab a shell or not, if your payload is able to communicate back or not. Now, if you look in here, not communication is happening. If you check your let's say our antivirus as well, is it being detected? Virus and threat protection says no action needed because nothing is being detected either. So there's a mistake in my script. So let's correct this. We have alright. So in here, let's try the PowerShell. This is not working as expected. So let's try a PowerShell. PowerShell has been created. The PowerShell script was being created right now. So you can check out the script on this PowerShell. Still making use of the same process, the same requirements, then still same technique by generating a random string, just that the payload is different this time. The payload this time is no longer bash, but rather I'm making use of a PowerShell TCP reverse shell payload. So here is the payload. You can always get your payload from Pentest Monkey. Pentest Monkey is a very good place for you to grab payloads, but most of the payloads there are payloads that are easily detectable. So what the obfuscator.py does is right now is that what it does for us is this script. What this script does for us is to help us obfuscate that particular payload in such a way that it's able to bypass antivirus systems and also do more things. Now I've started a listener on this port. I've started a listener on this port 4444. So my listener is running there. I'm going to type in the command for this PowerShell script by saying Python 3 PowerShell, then my IP address, which is the attacker, the listener, followed by the port I want to listen on and where I want to write the file to. So let's work with this file. Now this creates a encoded payload which can be used to bypass antivirus systems, then all the signature based antivirus systems as well. Now if this payload is being clicked on, please don't forget I still have the antivirus on, so that there would be no such thing as cheating. So the antivirus is still on. Now if I should double click on this file right here, it brings it up like a normal Windows update manager by you saying maybe it's trying to update your system, but rather in the background what it does is to send a listener to this particular listener I have here, and you can see that the target 192 this on this port has sent a reverse shell back to my listener. Now if I should try and list in here, it shows the content of my target. You can see that this is users desktop Kali, but you will see that this is Windows, not Linux over here. So I can say I'm going to the directory this cd to you can cd dot dot. You can go back. I can choose to say cd to let's say c, then adding it this way. We are going into the directory users. If I list here, I can see two users here. Public user, this is me being in the target system because it's able to catch a reverse shell. And if you look at antivirus, I'm not able to detect I'm not able to detect anything over here as well. So I can go into different directories. Let's say I'm going to the directory public. If you list here, you will see this user credentials as well. So this is what I'm trying to bring out with the obfuscator, and I hope you guys are able to learn one or two things from this video. Please make sure to drop your question in the comment section, or if you do not understand something, so that we can quickly talk about it. But I want you to understand that the real strength of this framework is its extensibility, because if you want to add a new obfuscation technique, you can just add a new method to the class. You can add maybe XOR encryption, you can add environmental keying, you can add time-based execution, you can add fileless execution techniques, different kind of techniques. Now, after generating a payload, what our tool does is to provide a detailed report, techniques applied, the payload size, the execution instruction, and things you need to know about the payload before it is being sent to you. But please note that we don't just deliver the payload anyhow. The way you deliver your payload is very, very important in a situation like this, and you need to make use of what they call social engineering tactics. Please note that this is for educational purposes only, and if you have any question, please feel free to reach out. We'll be glad to hear from you. Thank you very much.